Greetings, fellow mathematicians. We're going to take a look at the problem of how to find the derivative f prime of x by using the limit definition. Now, there's a big difference between an earlier limit definition for the derivative of a function at a point a, and now what we're calculating is just called the derivative of a function. The big difference, the derivative of a function at a point, that comes out to a number. And that number represents the slope of the tangent line at that point, x equals a. Now what we're going to be calculating is a very similar limit definition, but it appears as if we're changing a everywhere to x. And this has the big effect of changing your answer from a number to now you're going to get a function of x at the end of this. That function of x is what we call the derivative. Now, before you go through this problem, there's a lot of similar steps and tips that we gave earlier in a video linked down below in the description for the derivative of a function at a point. All those steps and tips still apply, and we basically have the simplified versions of the steps written off to the side here. The big ones are written because we're calculating a difference. We're going to use parentheses around what we're subtracting. So parentheses around f of x. And there's a check built in here in step 2. All terms that are left after you fully simplify the expression here in step 2 should contain h. So we'll see that in action here. And another tip, which again we mentioned in the video linked down below in the description, was when you have a function defined as a fraction, instead of in step 3 of dividing by h, it might be simpler to multiply by the reciprocal, multiply by 1 over h. And that'll allow for some cancellations to be a little bit more obvious. Now, if you're ready, let's jump straight into this problem where our function of x is f of x equals x squared. And we're going to apply the limit definition to find the derivative f prime of x. All right, so let's jump straight to the first step. We're going to take our function and plug in all x's as x plus h. All right, and that's pretty simple here. Our function only contains one x in it, so we're going to get x plus h squared. And that we can simplify by correctly expanding that and multiplying, foiling that. We're not going to just square each term. In other words, this is not x squared plus h squared. So be careful, foil that. X squared plus 2xh. Those are your outer and inner terms. And then we get plus h squared. So that's pretty much it for step 1. Step 2, this is where most of the work for these problems occur. We're going to calculate the difference. Again, this all goes back to a slope formula, y2 minus y1. And here we're subtracting y values. And y values now, we interpret them as coming from function values. All right, this is going to be where you typically might want to use parentheses because we're going to take f of x plus h and we're going to subtract the original function, f of x. Now here, we don't actually need parentheses around f of x because the function here contains only a single term, x squared. This tip of using parentheses, that's really going to pay off if there's several terms either being added or subtracted in the definition of the function. All right, so let's go ahead first with what we just calculated. We have f of x plus h, which is those three terms, x squared plus 2xh plus h squared. And now we're going to subtract f of x, which is just x squared. All right, and if you take your time and simplify this, this one is very simple. This will pay off for the more complicated ones that we, again, have linked down below in the description. Take your time here and fully simplify it, and you should find that the check occurs. This is a way to check your work. All terms that remain after you simplify it should contain h. And that's going to be what cancels out in step 3 when you divide by h to eliminate the indeterminate form. So if we go ahead and simplify here, the x squared subtract out, And looks like we get our answer here as 2xh plus h squared. And if you're already thinking ahead to step 3, dividing by h, notice here, because every term contains a factor of h, you can factor h out. And you can write this as h times 2x plus h. And for this problem, again, this one is very simple, but that is most of the work for this question. All right, that was step 2. Now we can go to step 3, which is dividing by h. So we're going to have here, this was the numerator that we calculated in step 2. We're going to take that and divide by h. I'm going to write everything out since this is our first problem. This was our numerator, h times 2x plus h. And now we're taking that and dividing by h. And here, because we factored h out in step 2, it's really obvious that you can cancel out that common factor of h, and we get as our result for step 3, 2x plus h. And our last and final step, remember this is called the limit definition of the derivative. Don't forget here, your last step, we're going to take a limit as h approaches 0. But like in the previous problems of calculating the derivative of a function at a point, all your work here, steps 1, 2 through 3, that's basically to eliminate or cancel the indeterminate form. So once you get down to step 4, you can typically evaluate these limits just by plugging in h as 0. So let's write everything down. This is going to be what we call now f prime of x, which is defined as the limit as h goes to 0 of this. So let's write that. F prime of x equals the limit as h approaches 0. And now we can just take this, what we just calculated in step 3, and basically plug that in. That was that difference quotient, that fraction coming from the slope formula that we just simplified. So we'll be taking a limit as h approaches 0 of the function or expression 2x plus h. And here, just go ahead and plug in h equals 0. There is no more indeterminate form. And it looks like what we get for our derivative, that comes out to 2x. And there we go. Again, this one was very simple. It only contained one term, x squared, and these steps really weren't too bad. All right, now if you take your time, like we did here, you'll be able to get through these problems. And the big change, which I want to mention, is going from this limit definition, the derivative of a function at a point. Those calculations, while tedious, they typically had a lot more numbers in them. Now, because we have x's in place of that point a, you're going to have a lot more x's, variables floating around, and that's going to make the algebra a lot more complicated and tedious. So definitely make sure to really take your time through here, again, like we did, and you'll be able to get through these. Now, one thing I always like to do is just to take the function that we're given, which was f of x equals x squared. And I'm just going to write what we just calculated, the derivative, right below. So if our function f of x is x squared, the derivative, we calculated that as 2x. And that is what we are after here by using the limit definition of the derivative. Now, shortly after this, in your Calculus 1 course, you'll be getting to something called the power rule. And that step of calculating a derivative will take you all of maybe 2 seconds. But here, our focus is on using the limit definition, a standard question that you're going to be asked in your Calculus 1 course, probably on your first exam. Hope you enjoyed the video. I hope you're learning a lot from them. If you are, support the channel, like and subscribe.